Moving right on, here's a word that we don't often utter in a cybersecurity conference. The word is predictable. Yet, our next speaker would argue that the way hackers exploit vulnerabilities over the network can be predictable. In a world where attacks evolve, but the SSL specs stay the same, how long before we don't even need to concern ourselves with decrypting the traffic in order to carry an attack? It's quite nice that Ionuț Cernica is going to take the stage. He's a penetration tester at UiPath and a seasoned competitor in the security contest world. It's great that he follows up after an introduction to bug bounty hunting because he's been doing this for the past years and he's racked up more than 100 participations in such challenges. He's here to tell us all about the results of his research related to leaking data over SSL. Ionuț, you have the stage.
Thank you, Alexandra, for the intro. Let me share the screen. Not this one, but the one with the presentation. Okay. So, hack the hackers leaking data over Ssl Tls. Welcome, everyone. My name is Ionuț Cernica. And first of all, I'll have an introduction about the blind injection. What is the problem with the blind injection? What is a blind injection? Scenarios and challenges, then I'll go over to blind injections over Ssl Tls, then will be the demo time with the known tool for SQL injection, SQL map, and my conclusion. Who am I? I'm a penetration tester for UiPath. I'm also a PhD student for Department of Computer Science, Polytechnic of Bucharest. I'm also a CTF player, mentor, because I want to give back to the community. Sometimes I do bug bounty hunter. I do bug bounty. I'm searching for bug bounties in bug bounty programs, and I'm ex-entrepreneur. So, blind injection, how it works. So it's about extracting one byte at a time from each position from the information by querying the server for true and falses. So this kind of technique is done by in two ways, Boolean and time-based. So where we found this kind of technique in lots of vulnerabilities like SQL injection, remote command execution, when you have to get one byte at a time. But the most common is in SQL injection. So there is a blind SQL injection. Problem? Maybe not, but we can distinguish the true and falses from the encrypted traffic by looking on the length of the responses or just the delays between the responses. The real problem, I introduce you BLOST. BLOST refers to blind injection leak over Ssl Tls, which is a passive attack. There is no interaction with the victim. So our blind injection exploits maybe are written in a predictable way, and when we are trying to exploit over the network, maybe we can do some steps, some reverse steps to get the same information as the hacker did. How's that? Because when we're writing on blind injection exploit, we feed our method with an input. That input is the leak, and we have the two types of output. We suppose from the encrypted traffic the true and false. The true and falses. If you suppose correctly this, we just have to make a feasible brute force on the method that was used by the hacker. And by having the method and the output, you just recuperate the input, which is our leak. So known methods of exploiting with blind injection techniques, we have the char set method, when you construct your char set by creating the letters A, B, C, D to Z, and then you put in the char set as well the digits 0, 1, 2 till 9, or you have some optimization techniques like binary search. This is used by a lot of tools like SQL map. There are other tools to exploit blind injections, and other tools use, but there is not so common. I don't remember right now the name of the tool, but there is a tool which is using bit shifting technique to exploit blind injections, SQL blind injections. Challenges with the extraction methods. So I I saw that there is no challenges when you are dealing with optimization techniques, like I mentioned earlier, like binary search or bit shifting. But there is a big problem when you are using the hacker is using the char set method, and this was the biggest challenge, because we don't know how the hacker constructed the char set, because we don't know if the char set starts with digits or starts with letters and so on. Maybe he has some extra characters in the char set, and this problem, you can solve this problem by making a rotation like Caesar. You have some crypto stuff problems, but it is exploitable, this char set method. It's harder, but not impossible. Exploiting over SSL TLS, we have the length of the packets in the encrypted traffic. We have the time between packets if it's the time based. Then even there is a padding involved. Some cipher encryption has some padding involved in some cases. So we still exploit the problem if we are lucky enough that the block size is smaller than the difference between true and falses. So we have the padding. So the truths should be bigger or smaller than the falses, the length of the true, and the length of the false should be different. And I should mention from the beginning, but now it's an opportunity, that there is no problem with the SSL TLS protocol. So because of that, there will not be a change in this protocol, but it should be in our way of creating the blind injection exploits. Scenarios of exploiting. So if you are a penetration testing company, imagine that how many times did you get the I don't know, the database from a client? Maybe a lot of times, maybe. And how many times did you get through blind injection? Several times, maybe more. But maybe you didn't know that when you are taking the database from your client, those important data, which you shouldn't have or no one should have, are leaked through the encrypted traffic. So this is one of the scenarios. Another scenario implies the internet service provider. He has the encrypted traffic. Maybe he can start digging for, I don't know, script kiddies and professional ethical hackers and so on. And maybe, why not, one more reason why large countries have a strategic interest to pass the traffic of another country through their infrastructure. Maybe they are digging for some other information, and one of them maybe should be, it is like this one, blind injection exploitation. As a future work, maybe you have some exit nodes over Tor. So if you have exit nodes, maybe you are aware about the cell padding. There is a cell padding in Tor, and you can start at least digging in your encrypted traffic, because you have just encrypted traffic there. You can start digging for information from script kiddies, professional pen testers, and so on, hackers, for dumped databases. Tools and exploits database. Sorry, just 1 second. I analyzed a lot of tools. I analyzed a lot of databases that has blind injection exploits, and we found, with no exceptions, that those tools were vulnerable because they were exploiting the blind injection in a predictable manner. So the same thing was with the blind injection tools that they are exploiting with a known optimization technique like SQL map, or the other tools like they are using other optimization techniques like bit shifting and so on. In Pontai by CTF 2 years ago, I created a task, and I have the access log from that task that I created. I ran a script to trace the tags, and I created a script to extract the information just from the access log, because the access log has the response length. And I found 7 unique IPs. So the task was solved by 5 teams. And I found 7 unique IPs that extracted the flag by running some scripts against those access logs. And five of them was with the charset method, and 2 of them was with the SQL map. And I was able to take the information back from those access logs. So I'll make a demo. Okay. Let me start the demo, the video. So I'll take it from the beginning. So here is the demo, which implies 3 parties, like the penetration tester in the left. In the middle is the man in the middle, which he has only access to the encrypted traffic, and the vulnerable web application, which is in the right side. So in the first of all, the penetration, I have to mention that the penetration tester is already found a vulnerability in the vulnerable web application from the right, and he's starting an SQL map against the vulnerable web application. And the man in the middle, so he just started the SQL map. Man in the middle of the demo, of my demo, he's starting a TCP dump to take the encrypted traffic. You'll see later that those lines from the encrypted traffic are encrypted, and we don't need more. We don't need more than that. We just need the encrypted traffic, and that's all. So the penetration tester, as I mentioned, he already started to dump data from the vulnerable web application by exploiting it. And soon we'll see that he finished the SQL map. I will stop the TCP dump from the man in the middle. After the penetration tester will finish with the SQL map. Just 1 second. So man in the middle stopped the TCP dump as well. I will put the TCP dump file on my Windows machine to open it with Wireshark to show you that I have only encrypted traffic, the client hello exchange. So we don't need any more than the packet length in this case, because was exploited through the Boolean technique. So I extracted in demo CSV some data like packet length, and then I run a Python script against the CSV in order to take the true and falses. So now, first of all, I have to mention that the man in the middle has the encrypted traffic. He started to take the packet lengths and process them into true and falses. Right now, he processes the encrypted traffic into true and falses. Okay. And now to leak the same data as the penetration tester, right now there is no interaction involved. So man in the middle will not interact with the vulnerable web application. So he is not sending any request to vulnerable web application, and he's not sending any request to penetration testing. So there is no interaction, which is a passive attack, which is very, very bad for the affected parties like penetration tester and vulnerable web application. So what I do now, I created a dummy database on my man in the middle. I will start to exploit a vulnerable blind injection on my side, which has dummy database and dummy data. But after the SQL map finds the SQL injection, I will start the SQL map. SQL map starts to find the SQL injection. When he finds the SQL injection, I will start to tell the SQL map to the application to feed the SQL map with the same true and falses. You will see soon. So I have my SQL map. Now, right now I am creating the database, which is in an important step of the exploitation. Of course, you can make all these steps by creating a script, but it's not fun to show you like that. So that's why I choose to feed my own SQL map with the same data, like this one, true and falses. I already have the true and falses. So I will feed my local SQL map with those true and falses. And you'll see the result soon. So this is my local vulnerable web application, which is vulnerable to SQL injection. SQL map starts to confirm if it's vulnerable or not. Okay, so he's testing for MySQL database, DBMS MySQL. And right now, I'll comment the code which is with the vulnerable web application, which is vulnerable to SQL injection. And I will start, look, right now, he finds that the URL has an SQL injection. No, he's still testing. Okay, right now, he finds out that ID parameter from get is vulnerable to SQL injection. Right now, you just have to answer with those true and falses, nothing else. And I'll make a change in my application to respond with those true and falses. And pay attention what's happening. So right now, I will save this file on my server. And I will serve those true and falses from the session. Look, he's just getting the same data as penetration tester took from the vulnerable web application through the same technique. So there is no losses from the process. I'll have the same data. Okay. Go back to my presentation. So what we did in the demo, so the penetration tester from a company, A, let's say, exploited the vulnerable web application, and a man in the middle took the encrypted traffic and did a passive attack with no interaction with the penetration tester or with the vulnerable web application. So penetration tester and vulnerable web application, they have no way to track the hackers at all. So the man in the middle took the encrypted traffic, and in the same time, he did a passive attack. So, as I mentioned, no interaction between those parties. And he extracted the true and falses from the TCP dump encrypted packets and feed his local SQL map with the same true and falses, and he leaked the data. And the result is this one. So he was able to take the same data as the penetration tester did. So he has nothing less, nothing more, the same data. So how we fix this problem? For charset method at DefCon, because I had the same presentation, I have most of this presentation was presented at DefCon this year in Las Vegas, and I said at that time that we have just to shuffle the charset. But it's not a good idea when you have lots of data, when you dump lots of data, I don't know, megabytes or gigabytes of data from the database. Why? Because all the process, okay, you shuffle the charset, you have randomized the order of the letters, but the problem now is that you transform this problem in a substitution problem, and you can take the data anyway. So it's not fixing the problem if you randomize the characters. What is fixing the problem is by adding some extra steps, even for the charset method, for the other optimization methods like binary search, bit shifting. You just have to add some extra steps in your exploit, and you just won't take them into account when you are exploiting. So my conclusion, the way we write blind injection might be predictable, and we should pay attention on how we write those exploits. And when we want to run a blind injection attack, you must consider inserting random steps in the algorithm, so you can hide your your algorithm of extraction, and maybe this can be useful as a defensive technique. You can start digging in your encrypted traffic for script kiddies, for hackers that are trying to dump databases on your company. So it's like a payloadless detection against blind injection. Thank you. Do you have any questions?
Thank you, Ionuț. That was a very awesome demo, and I really like the setup that you had as well. Everything was so clean and it worked. So the demo gods were on your side fully.
Thank you, Alexandra.
I'm wondering, have you used this method as part of your professional bug hunting activity?
No, I can't do that because it implies to take encrypted traffic of other parties. So most of the bug bounties doesn't imply to have a TCP dump or something like this. It's something else.
Mm-hmm.
So I don't do that in my bug bounty activities.
I'm sure that even if you would have been doing it, you wouldn't have told us. So I think this is the correct answer.
Yes, but I think it could be used in some other things, like I mentioned Tor. If you have an exit node, you can start digging for those script kiddies or hackers and see what company leaked some data, some databases, and so on. I think it's a good starting point to go to, I don't know, to make this research at another level.
Mm-hmm.
I think.
I think it's a very dangerous kind of practice as well, since everything is passive and you leave no traces.
Yeah, there is no traces.
Yeah, it's like eavesdropping on people's conversations, but over SSL.
Yeah, it's very ugly.
Thank you very much for demoing this. And I think this was a very fitting end to the second day of DefCamp.
Thank you, Alexandra. Thank you all.
Thank you, and can't wait to see you again, hopefully maybe in a hybrid model where we can actually see each other's faces more than what Zoom allows.
Maybe next year.
Fingers crossed.
Yeah. Bye.
Thank you, Ionuț. Bye.
Thank you. Bye-bye.